in 2019. To his credit, he has more than 101 publications in international and national journals. He has handled projects of CPCB, CSIR, MHRD, NPCIL, HPCL, etc. and has filed 4 patents. He has authored 2 books and over 18 book chapters, and he is a life member of Indian Institute of Chemical Engineering and a fellow member of Institution of Engineers India. On behalf of SRETIA 2022, I welcome you, sir, to deliberate on the topic Electrocoagulation as a sustainable process for treating arsenic and fluoride contaminated water. Welcome, sir.
Okay, so very good morning, everyone. My sincere thanks to Professor Bhuvaneshwari for inviting me, and I congratulate the Equity of the Department and Professor Nishka and the colleagues as well. So today is the last date, and for around 21 seconds, it's a very long duration. Really, with the congratulations to organize as a workshop for this program for non-duration. Okay, so today we will discuss on this electrocoagulation and its sustainable process for treating arsenic and fluoride contaminated water. So now this is under this course, that is sustainable and robust electrochemical technology for industrial application. So keeping in mind the theme of this program, we will be discussing the relevant aspects under this area. Okay? So you all know that arsenic and fluoride contamination, particularly contamination of groundwater by arsenic and fluoride, is a major issue in our country, and not only in our country, around the globe. Number of countries are affected by this, and many people are affected by these two contaminants. And relatively, the technologies are available. This is not the fact that there is no technology. Technologies are available, but this is typical for Indian context, because the groundwater which is contaminated, that is basically rural India. The economic condition of the people are not that sound. I will show you some photographs as well, and our work. So you will see how poor people are living in that area, and when the water is not available or the water is contaminated. So the technologies which are available in the market, as best available technology, which are available, our people cannot afford that. So we need cheaper solution for a sustainable solution. Our people cannot afford that high cost technology. So on that line we discuss how can we, and we have a responsibility, all of us sitting here have a responsibility to solve a particular social problem. We should put our whole effort to solve a particular problem. If we need, we will collaborate. So that way, so what we will discuss today? Yeah. Okay, these are the outlines. So groundwater contamination in India, then you will see arsenic and fluoride contamination in groundwater and its impacts. Then available arsenic and fluoride techniques, then absorption and electrocoagulation as promising techniques. Then we will see need of more research for developing a sustainable process, and ultimately we will show our work which we have done. You see, what is the groundwater contamination in India? If you see GST, the Government of Science and Technology, Government of India site, you can go and you can search. You will see there are more than 250 sites, 260 sites there are water challenge sites in the country where either arsenic, chloride, nitrate, cyanide, heavy metals are present in the water, or personal care chemicals, seawater intrusions, and salinity are non-available. These are the major challenge sites. Water is being affected. Okay. So we have got an opportunity to work on this area under the Indo-France water network project. So we found out that arsenic and chloride both are available in the Arunachal district of Chhattisgarh, and TGS is also a major problem in our area would be there in Gujarat. So this can be the major problem of many other places, not just reported. TGS is a major issue. Okay, so we need to develop technology for these purpose, and we are focused here to do something for arsenic and chloride contamination, and also these one that is personal care chemicals, etc. That will the next class will discuss that grey water treatment, which one is this one. That way we are targeting one by one as per our capacity, and then the development of adsorption based low cost system for making arsenic and fluoride contaminated groundwater, and development of electrocoagulation based low cost system for making groundwater. These two areas we have identified as per our capacity and as per the background. If you analyze the most available technology for arsenic and fluoride removal, these two are, that is, this is not easy, but only formulation and adsorption has been reported in literature with more success and has been used in commercial scale. Okay, now we are trying to improve it to reduce the cost. Now we have some idea about the problem, say arsenic and fluoride contamination, the arsenic contamination only. So this is the map, global map, and this is global map. So India we are having arsenic contamination. Red points means you see this one, 75 and 100. That is more than 75 to 100 ppb, and sometimes you get even 500 ppb. Somewhere it is in 1 ppm also. So very rare. It's arsenic contamination in the groundwater. Okay. So what you see here, these are the different countries. You see, we are here, India, and this image is there is 2014 study. You see, this 100 million people and more than 70 million are affected by arsenic water. So this is the data, and if you see. In India, arsenic is, but this is a full map that was shown, but mostly West Bengal and Bangladesh, this region, and then other part also there are Gangetic belt. You see that mostly Gangetic belt, the arsenic contamination has occurred, apart from some area that is not widely spread across the country. Some other also. So these one is basically supposed to be due to the presence of magnetic flow water in the Ganga, and due to flood situation or any other reason, geological reason, this is affected. But in other places where we are working in Chhattisgarh, this reason is supposed to be different. This is maybe from the industrial effluent, so because there is some mines are there, so mine drainage will be responsible for the management part. So whatever is the reason, ultimately the groundwater is contaminated, and this is the statistic you see. So it's 17 report, 39 million people, more than 21 states are probably affected by arsenic. Drinking water. Okay, so this is chloride contamination across the globe. This is the map. So here we are also in India. We are also having the chloride. Maximum is Rajasthan, Gujarat, Maharashtra, Chhattisgarh, UP also to some extent, and many other European, Assam, Power we also having chloride contamination. So for 100 million people in more than 25 countries are probably affected by excessive fluoride in drinking water. So this is the global data. Okay. And China, India, Sri Lanka, South Africa, and many other names are given here. And this is our Indian context again. As I told you, that this part, Rajasthan, Punjab, Haryana, Gujarat, Maharashtra, Chhattisgarh, then Bengal, Bihar, and also Assam, largely affected by this fluoride contamination. And estimates say that estimated population affected in 2017, that is 11.5 million, between more than 19 states are probably affected by excessive fluoride. So these are the data. Okay. Then you see both arsenic and fluoride both are available in the water. So there is Assam, Bihar, Chhattisgarh, Karnataka, Haryana, Jharkhand, Punjab, region, and we have identified some region this one. So this is Chhattisgarh. And the effects you know very well because of arsenic content of cancer, and it is arsenic cancers. Okay, and fluoride also gives different type of mediates. Okay, we see how many years we see. Okay. So there is a problem fluorosis. Okay. Skeletal fluorosis. So these are the negative impact of arsenic and fluoride. There is a very advanced impact we can say. Okay.
Please go. Give some time.
Okay. Now, yeah. So what we have seen now that arsenic and fluoride is available across the globe and in India mostly, and so we need some treatment. Okay, as I mentioned, our people are not responding. Control by conventional. Now, what can be the most suitable technique for us? Okay, for that we need to review all the available techniques. What are the positive points? What are the negative points? What is the scope of improvement? That we have to identify. So that we are going to do now. The different the precipitation and coagulation, one technique. Another is your membrane-based process, ionization and absorption. These methods are recommended by EP for arsenic removal. That is best available techniques. So these are the tutorial work. We do not need to repeat. Now we have to compare which one has some potential to remove the arsenic and fluoride from that initial level which is available in India. That is first part. And second part, where is the scope for first reduction? Okay. So then, if we compare, you see, so if it is a precipitation coagulation, this is established method advantage, low cost of operation, widely used at local level. So these are the positive points. This is very cheaper related to others coagulation method, but it has some advantage also. When you are adding some chemicals, so there will be some overdose. Sometimes you might have seen that water is coming with smell. The bleaching powder addition is more or chlorine addition is more. That is also. So here the dose can be a problem. Okay, and your requires large amount of coagulants and hence poses threat for dissolved aluminum species. So these are the called and membrane-based process. This is effectiveness is very high. These are the advantage. No chemicals required. No effect of interfering ions and works under a wide range of pH. These are good points. But what is it? Cost is very high. Okay. So and secondary pollutants are also being generated. So high initial and running costs. So this point, from this point, we are rejecting it. Our people will not be able to afford it. to not work, put more effort on it. Okay. So then until there is scope for reduction. So I'll discuss. Some people are trying to do it, but that is also limited on cost. Okay, then RSS method, this is also high level efficiency, written taste and other characteristics intact, and then you're affected by interfering ions and pH. So again, there is high initial cost. So these two we may not explore. So what remaining to one is the absorption and the coagulants. Both are cheaper process efficiency, low treatment efficiency, but cost is also less. Here we are having low treatment efficiency, coagulation, but cost is less. Here absorption cost is less, but low cost materials may be used, highly efficient, because less skilled manpower. So these are advantage. Our manpower, our people are not that of that level. So these two methods will be more suitable for our people. So from this table, we are able to identify these two areas here, and then we validate it. How this can be? Say in India, this is the source of water, groundwater. You see, the people are poor people, they are also, so mostly they prefer to use the clay filter. So the clay filter to some extent remove arsenic, but when it is more than 50 ppb, then this system is not suitable. So that is cancelled. So by increasing the depth of the well to some extent remedy is possible, but still people got very less advantage of it. Okay. Then we see the limit. So 148 to 985 ppb arsenic is present in our groundwater. 3.7 to 27 ppm fluoride is present. So this is our workable range. Our system should work in this way. That is our most important part. And then we compare the 5 different techniques, the cost comparison. As per EPE report, you see this one, activated alumina, low cost, and ion exchange followed by that, and coagulation. So these absorptions and electrocoagulations can be the most suitable technique, can be validated from literature. Now we will validate it. Again, we validate from the data available on the basis of commercial technologies in India. So this is one example that is commercially applied. Okay. So alumina gate and ion exchange gate are used here. So from Cuba it is coming, so it is passed through this gate and distributed. So we were successful at that time. But gradually there are many issues are coming. Okay, so this what issues are coming? Now one is it's your deactivation. Okay, the regeneration of this is an issue, and maintenance is an issue. Okay, so then how to address this? To address this issue, some people okay, and when you are passing through back way, so there will be some clogging and pressure drop, etc. Some issues will be observed, and people try to modify and change the system. Or to okay. Okay. Then you see that people have also tried. Prior to our effort, we will try to use this method, absorption and coagulation method. Okay, absorption and coagulation method, and different than DPH Bangladesh. Okay, public health engineering, Bangladesh, B College. Okay, B College Howrah. So they have also developed some technology. Then we see Paul Tuckner technology is there, and then West Bengal PhD public health department, they have also developed technology. Okay, then RPM Marketing Private Limited, they have also developed technologies. Okay, and engineers, they have developed technology. Jadavpur University also have developed technology for this. Okay, so this is for all for arsenic removal. So all these removal technologies either based on adsorption or coagulation. Adsorption or coagulation because these are the cheaper options we have already mentioned. Okay, then these are some salient features. So what is this coagulation, sedimentation and filtration? This is Bangladesh technology. So this is the photograph how they coagulation and then air separation. And here also you see adsorption column fitted with QL. So here adsorptions on activated alumina. So here capacity 1.41 gram per kg. That is not very high. And then contoner is also 15 to 30 gram per kg. They have used ferric hydroxide. And West Bengal oxidation, coagulation, sedimentation, filtration, stepwise, step by step. So these are the different technologies people have used and got success. Although there are some limitations, price is high, 2.31, 2 rupees 31 paise per liter. So this one say a two chamber unit. The activated enhanced hybrid alumina adsorption they have used and fixed bed adsorber, ferric hydroxide. There is annealed engineering, but there are problems that 5 to 25 ppm GFH is remaining, so that is also not desirable. So the tablet and filter candle that university they consist of marjar, filter candle and tablet. Okay, but that also did not that success, did not get that success. Now we are coming to see the available technology for fluoride removal. So first one is Nalganda technique. So this is developed by Station Navy. So this is based on coagulation and sedimentation. Okay, and another Prasenjith technique. So they have activated aluminum waste. So these are also there in AlCl3 alkali. Okay, aluminum salt, lime, and bleaching powder in this case. So there is a chance of overdose, etc. So it has some limitation. And sulfur concentration in treated water is greater than 400 ppm. Okay, aluminum concentration is greater than 2 ppm. So these are some negative impact of it and limitation of this. And then Prasenjith technique, it is also workable. Okay. Um, Now you see different type of the coagulation and adsorption. These two techniques, and for arsenic and fluoride removal, these are the summary of different techniques available, or technology available for the treatment, and which are implemented in tested in the field already. But all those techniques have some drawbacks. What are the drawbacks? You see here, this 2017 report. So what is this? This is your International Journal of Environmental Research and Public Health. This issue. If we see 475 out of 570 ARPs, arsenic removal processes were not useful, or arsenic removal plants are not really useful. With 145 not even in naughty conditions, removal of arsenic by 264 ARPs showed arsenic reduction from 185 to 165 microgram per liter to 44 to 87 microgram per liter, which is above the permissible limit, not below the permissible limit. So these are the limitations, and 28% of these stations could not meet the guidelines of 50. At that time, 50 microgram per liter, but now it is 10 microgram per liter. So you see all the techniques which are being used, those are not that effective. Okay. So this was the driving force behind our effort, okay, to do something. Okay. So then we decided to develop some adsorption new adsorbents and replace coagulation by electrocoagulation. If you can replace coagulation by electrocoagulation, we are getting two advantages. One is we do not need to add additional chemical. Just controlling our voltage or power supply and duration time, we can manipulate the concentration of the coagulants, your adsorbent generated inside or coagulants generated inside. So that is one major advantage we will gain, and by this way we will be getting the performance of the coagulants much more than the conventional chemical one. That was the reason why we worked on it. And then we tried to use some low cost material for the development of adjuvants. Our objective was to, one is to develop a filter for individual home. Okay. And another is in a community, say one village is there, see there are say 500, 150 houses are there. So 400, 500 people will be there. So how much water there is living. So that capacity plant we need. So that plant we are working on it and to develop individual. Anyone can use it. So 20 liter is sufficient. So 20 liter per day can get that will be very good. So that way we can. And you see, our preliminary study we found that operating cost of PC process is around 0.03 per liter rupee, that is 3 paise per liter. 1 liter water treatment cost is around 3 paise. So that was tested in our lab in 2017-18. Okay. So then we are encouraged. So why not to explore further? Okay. So then again, there are some, confusion whether we should put effort or not. Then, is there any success on this process? Because electrocoagulation process is not a new concept, but its application in wider scale is a relatively new one. Okay, wider scale to handle a large volume of water, it is not that good. So we searched and we tried to find out, is there any example? We got this group, the Gatkill Lab USA, the Berkeley, California, they have developed and they are implementing it in our country, in West Bengal. Okay. So American people are thinking our solution and they are coming and they are setting up the plant for us. Okay. You see. So this ECAR, electrochemical arsenic granulation, this method, okay, what is happening? Electrodes, cathode anode, and then electrode is iron based. So iron hydroxide is produced. Iron hydroxide is helping to oxidize arsenic 3 to arsenic 5, and arsenic 5 is being settled down. The mechanism is that. So that way, they are able to produce. This is the estimated 0.03 USD per person per day. That means what is the cost now? Can you calculate? 0.03 USD per person per day. 0.03 is 20 how much? 2.4. Okay, 2.4 rupees per person. One person, how much it can be? A liter drinking water. So what is the per liter cost? In paisa, how many liter are you getting? 1 liter for how many paisa? And this paisa hoga. Okay, so this one is there. So another technologies that is there. So electrocoagulation, which we are discussing here, that is the dissolution of the electrode dissolution, coagulation formation, coagulants formation, and then settling of the pollutants. So that is the mechanism. Here another mechanism is used. In this case, this is Germany. The German people are working, and their plant is running in Haridwar. Okay, near to our identity, the German people are working. They are installing plant in our identity. Okay, so you see here, so what is the mechanism? Here, the electrocoagulation means dissolution of electrode is not taking place. Okay, the mechanism which is present, the electron means electron is released, and then chloride, chlorine and electron and then this is reacted with water, and then this O2 and then this plus likewise, and then chloride, which is this chloride which is present in the water, that is converted to chlorine. That chlorine is reacting with H2 and giving HClO. So this HClO is helping the reactions. What reactions? HUCl, H2HUCl plus 2Ap2 plus and H3O, so APOOH plus Cl minus plus H plus. So this H3SO3 reacting with HClO and then H2SO4 minus. This is the mechanism for removal. So no, that dissolution of electrode is not necessary. Okay. So there will be some reaction and then separation, filtration unit. So that way we see that the filter with a depth of 66 centimeter and a diameter of 17.7 centimeter, accounting to a media volume of 16.3 liter. So this is their technology. Okay. Any question after this? Or question will be at the end.
The issue of chlorinic of development of gases when they react with organic compounds, they produce by having this kind of gases. How to encounter that?
Which are in which case?
In this case, like we are adding. So,
This one?
yeah.
Yeah. So in this case, what is the concentration of organic compound present in groundwater? Well, in our system we don't have other compound. No. Purity is nil. There is no purity in the purity. So how come the organization? Okay. That will not work. Okay, then you see some other. Any question more? Any more question? Then you see here, ECA is potential option for low cost treatment. So another unit capacity 10,000 liter per hour. So you see that 10,000 liter per hour is available. So 10,000 liter per hour means how many liter per day? Anyways, 24 into 10, 240 KLD. 40 KLD is also good amount of water. Okay, so that is this plant is available. Okay, with the tank of 2000 liter. 2000 liter. So this was there. But this wastewater is fed into the chamber from the bottom of the chamber and discharged from the top. So this is the from the bottom and discharged from the top. So this is the case. And HRD residence time was 20 seconds. Industrial wastewater. So this is applicable for a special type of wastewater. So 20-second residence time is too late, but it is giving the work. That means the concentration of pollutants in wastewater is not much. Okay, so that is why it is giving that high volume. Then another, you see here, electrocoagulation system at PMP. It is electrocoagulation process for wastewater treatment that is in Australia. So this is another system they have used, and this is another system. The EC cell was composed of a basin that is 65 centimeter, 20 centimeter, 5 centimeter, made of austenitic steel and 6 aluminum parts. So this is the dimension, and the aluminum parts were rectangular, and the gaps between these were 2.5 centimeter, and minimum and maximum working volumes of around 70 liters and 25 liters. Okay. Continuous operation is at 6.5 liters. So here the effect is more. Okay. Use for wastewater, no sludge management. So they did not focus on sludge management, and utilization of electrocoagulation for water and wastewater treatment and nutrient recovery. So this is the objective of their study. And this another study, this is Indian study, okay, for home use or home use. You see here A, B, C, three part, and this is the part of this varies from IB Guwahati to A, B, C, three part. Then 15 liters, 9 liter, and then 8 liter. So the current density is 625 amps per meter square, and an electrode distance of 0.05 meter, no slab arrangement, PC of 45 minutes. So 45 minutes PC electrocoagulation time they have used for the removal of this equipment. And here some another study for industrial scale application, that is your for the removal of PSAs, heavy metals, emulsifiers, bacteria, and other contaminants from water. So this study you can access from this. Then this system is suited for applications such as oil and gas produced water, mine process water, industrial storm and wastewater, and construction storm water. So this water, so here issue, and then this is filter. So this is the report of some EC-based technology used for the wastewater treatment as per the literature. Okay, that's some inspiring thing. So what we guess from this, that electrocoagulation has potential. Okay, this method has potential to be used in the treatment of the contaminated groundwater to remove arsenic and fluoride. Alright, from the can you please can conclude from the discussion that you have made. We can do that. Okay, but we have to modify, we have to develop our own system for our own application. Because we have never seen any system which is describing the working of working with wastewater having the concentration of arsenic and chloride present in our country in the same way. We have not seen any example. So we have to do that now. Okay. So then, therefore, it seems that EC process can be applied for community scale application. Absorption process can be applied for individual household. Why so? I have already given you the past figure in India. People try to use the paint as a heat of the tube oil, but then did not get success. There are many issues, maintenance problems, did not get success. So this process, absorption process, will not work in that commercial or community scale, but EC can work. EC can work. Okay, and this absorption can be used for the household device. And spent adjustment and EC sludge management is an important issue. We have not seen any such report. Because I am taking arsenic and chloride from water to solid. Then what do we do with that solid? That is a great question. And we have to justify that. And then life cycle analysis may help to conquer the sustainability aspect of these two processes. Now we have two options. So which one we will recommend? Which one will prefer? That can be judged by the life cycle analysis. So that's what we have to do. And then more investigations are required for the development of a sustainable treatment process. So on the basis of the background, on the basis of the existing technology, we are in a point to conclude that these are the need of the day. Any query, any question, any doubt on it? No. Very good. Now we are doing what we have done. Okay. Now can you guess what type of knowledge we should have if we want to develop a new system for us on the basis of our background? Can you guess what type of knowledge we should have? We should know the working of the adjournments, how an adjournment works, what is the principle, what is the scope for development, how we can monitor the capacity of adsorption of adjournment. To know all this things. The first part. So we have already completed that part prior to this review. So let us have some discussion on that. That will help us to understand further. Okay. So what I have done, this is my PhD work, my own PhD work. At that time, arsenic, let's say 2004-06, arsenic removal was a great problem. Okay. And there was no technique to in our country. There are no technique to separate arsenic 3 and arsenic 5 and analyze them and classification. Okay. We also developed one technique for isolation and for that. And at the time we were working with activated carbon. So granular activated carbon we are working with. And you know that granular activated carbon is used for wastewater treatment for the removal of various types of pollutants. Can you guess why so? Why activated carbon can capture hardness? How I can say not fluoride, right? It's a because this is or it can take say metal ions. Okay, it can take say sulfate to some extent. Why? Any idea? Because the surface has both positive and negative charges. The surface has both positive and negative charges, so chemical will take place. Another physical adjustment will also take place. That will be taking or annexation can also take place. But now, if I want to get more chemical offset for a particular type of species, like say negative species, I want to get more adjustment, chemical, then the surface should be positively charged. The surface has to be positively charged. So that effort was there. So we tried to change the surface, modify the surface by the impregnation of metal ions. Now aluminum and calcium, I have two metals. Which metal will be able to give more charge? Aluminum and calcium. Aluminum, because aluminum plus 3, calcium plus 2. Now you can guess what type of metal should be used for this. The iron, aluminum, this is the value metal. Observe, mostly iron oxides and aluminum oxides are oxides that we use as a metal because of that reason. Okay, then we see that if we have say these one positive, negative ions are there, so in the surface of the activated carbon, now you are manipulating it. So some Ca2 plus will use one negative is neutralized, another positive is added. So overall surface charge is increasing. So arsenic which is present in negative charge in the water that will be captured here. Okay. Again, arsenic has unique characteristics. You know, if you change the pH, its negative, its chemical nature will change. Okay. Cyanide is negatively charged, cyanide is 0. Up to pH 7, arsenic 3 is 0. After that, it is negatively charged. So, pH of the solution will play a role to decide the charge of the arsenic, and pH of the solution will play a role to decide the surface charge of this adsorbent. pH ZBC is there. pH ZBC, zero charge potential. That is the pH at which the surface is 0 charge. So that way we can guess and we can design the adsorbent, and you know that there are three types of mechanism: physical, chemical, and this ion exchange mechanism. Okay, but ion exchange mechanism can also help for the capture of arsenic or any molecule. Okay, so we have to change our surface accordingly, keeping in mind the possibility or possible rules for the adsorption. Okay. These are, we have to understand the mechanism. Either arsenic 3 is captured by the adsorption, or arsenic 3 is converted to arsenic 5 and then being absorbed. So that way, FTIR analysis will help you. So here you see arsenic 5 peak we are getting here, this type of arsenic 3 peaks we are getting here, this peak is not there. So that way we can guess arsenic 3 is converted to arsenic 5 prior to its absorption. Okay. So then different types of metals we can impregnate. Thinking about the charge, say copper, calcium, manganese, and then iron. So they are having different characteristics, different removal capacity, more removal capacity. So I think this is your iron. Okay, so iron will be having more capacity. So that way we started. Okay, so at that time we thought that this absorbent can be a competitive one, but at that time it was competitive, but now it is not competitive. Okay, so at that time it was competitive, but today it is not competitive because many people want and develop other alternatives. So that is a good, challenge to develop something new and which will be very effective. We spend our time, but did not get success. No. Okay, that success got to identical at that time. So they have developed some other materials with more capacity. We felt no problem. Okay, failure is the process of learning. So you see how it failed. So it's fine. So cost of activated alumina 130 per kg and cost of activated carbon 25 to 40 per kg. So that way maximum specific uptake activated alumina is this one. Okay. And uptake your now nucleated activated alumina was this much and maximum uptake BGCAC was this much. So this was similar, but later on new adjuvant came, and this ACAP was not competitive. Okay, but from that we learned many things. All those things, what we should know about this, that we got. Then we started with other material, that is your laterite soil based adjuvant. Laterite soil based adjuvant because this is natural product, cost will be less. Okay, and aluminum hydroxide and nanoparticle based adsorbent. So this is aluminum people are using. Aluminum which is chemically synthesized. We try to synthesize aluminum from electrochemical. Okay. If we change the route, then what will happen? Production cost reduces. Okay, because lot of your purification steps etc. is nowadays. Okay, and then that way cost is reduced and quality is also maintained. So this is one advantage of AHNP. And this is ABTL, surface multiplication of ABTL, the acid base treated laterite style. So acid base treated laterite style we have produced. So these two approaches we found that these are still relevant today. These are competitive to with other adsorbents available in market. Okay, so that way we found. So what was the step for ABTL? So leaching of iron and aluminum ions in acidic solutions. So our objective was to leach this one in the solution. Then, so at first the acid treatment was then this is the role of acid treatment. So I83, O4, Al23 available in the laterite style. Those are coming into this 83 class and 83 class and aluminum 3 class ions in the first solution. Then we are excess amount of HCl, then it is vaporized. Okay, and then distilled and then it is recovered. And third step is to add alkali. We are adding alkali, so iron and aluminum which species was available, that is converted to iron oxyhydroxide precipitate. Okay, aluminum oxyhydroxide precipitate on the surface of this. So this is our laterite style. After acid bed treatment, we are getting this is our final product. So this by this way we see that there is significant increase in the arsenic and fluoride removal capacity. Then what we do? Another material that was developed that is electrochemical based. Aluminum electrode. So this this is the mechanism. Aluminum will be Al3 plus and H2 H minus, so that will give us AlSO3 plus. And this AlSO3 will be more hydroxide ion can add with it and it has polymeric structure and then this is sintering takes place with this after removing and drying and then sintering we get this adsorbent HNP based adsorbent. Okay, so this adsorbent is very both arsenic and fluoride removal capacity and it has potential to become into the commercial scale application. Okay. So then okay. So this is what your adsorbent development. We got to adsorbent. Then we have to verify it. How we do it? Now I am going to give you clear concept how to convert laboratory knowledge to field. Okay, convert to apply in the field. So then our objective will be to do some experiment lab work. So where I will get the groundwater sample, I am not getting. I have to visit some place, collect then the lab. But I know that what is the composition. So similarly, we will make some synthetic solution. That is followed in the lab. So then synthetic solution, arsenic we consider 100 to 1000 ppb. Why? Because we have seen that somewhere it is 500 ppb, somewhere 980. So this is our maximum range we covered. And then your chloride, we have taken 5 ppm. So most of the cases it is 5, 6 or below 5, and some cases it is like this. So that way we have this range of concentration for ABDL and range of concentration for AHNP. AHNP we have taken 30 ppm because its capacity is more for the your chloride removal. That way it was done, and then again to validate, how we validate the results, we need the real water sample that we collected from the district. So then that was used in our lab for the validation, and we found that which we are expecting on the basis of our lab, that is what that same result we are getting with this one, even we are getting better result. Okay. So which removal we are getting with synthetic water, we are getting 1.5 times better result, better removal in real water sample. What is the reason? Because there are many other metals in the water that is helping the removal of the acidic chloride. That's why we got that one also. And then you see composition of real groundwater. Now this is the composition real groundwater. You see one, then we simulated also one real groundwater which is collected from the field, another simulated groundwater. So it is pH 6.8, 27.2, 25, and 11, and 1250. Connectivity and arsenic 500, 500, chloride 6.3, 26, and iron 3.5, 3.5, 19, 42, 42, phosphate 3, and total harness 105, that is 150. Result of the 4 and 3, and third is 70. So these are the some laboratory we have to simulate the same. We cannot take only arsenic and chloride. We have to consider all the parameters and try to make as much as possible to simulate. Then performance of then experimental run. At first, while we do, we need to get the adsorption capacity. Otherwise, we cannot design at all. We have to get the adsorption capacity, and that is done by batch scale study. Do batch reactor study. So this is batch reactor study. So there are certain RPM, certain volume is given, with certain adsorption dose, certain time is given, and optimum conditions are found at K7, adsorption dose 20 gram per liter, ABPL 20 gram per liter ABPL, and 8 gram per liter ACL. So 20 gram per liter AL, ABPL will never come in commercial scale. 8 gram per liter that is also bigger, but since it is dealing with high concentration of fluoride, there may be possibility. But this is the higher range of adsorption dose. Okay. So from initial study we can guess whether this has potential to come to the market or not because of this. Okay. That way, then if we are getting the maximum specific uptake from the batch scale study, that has to be validated in a column study. It is the steps for development. So column study, why so what is the need? Because in the batch study, your adsorbent amount is less and it is giving more contact with the water. Okay. But in fact way what is happening? We have more adsorbent water pollutants are less. Okay, so critics are not same. Eliminate is okay, but the environment or the situation is different in that case. So sometimes pollutants which are removed in batch scale with certain specific uptake. For some pollutants in the column study, they give better performance. They are more reliable by unit gram of absorbent. But some pollutants are there negative impact also. It is not necessary that every time you will get better result in column study. Not true. Sometimes you can get less result also with respect to batch. Basically. So we have to validate it. So this is our column. Your bed height. So what type of variation we can make here? One is your bed height, another is your flow rate. That means the flow rate, more the flow rate, lesser the residence time, higher remaining the same flow rate, higher the height, more the residence time. So that way, main factor is residence time. And what is the flow rate? Flow rate will also changes uh, the contact basically. One is time, another is your time turbulence, that those factors will also play a role. So that is why we have to study these two basically. What should be the flow rate? What should be the residence time? These two are most important. Okay. So this type of investigation was made. Then these are presented like this. So arsenic and fluoride in the synthetic solution. So here fluoride 50 ml per hour, and 70 ml per hour, so 20 centimeter per hour. So then ABPL, then 10 ppm and 500 ppb. So this is our solution. The concentration of fluoride and arsenic, and carbon diameter 1 centimeter, 25 gram. So 25 gram adsorbent was used. This is the first. Okay. Then these are the results. What we see with time, so this is ICU, C by CO. So this is the concentration of the arsenic at certain time, and this concentration is ratio, and with time, it is like a breakthrough curve. So here, our permissible limit is how much? Permissible limit is 10 ppb, and say what we have? We have 500 ppb. So 500 ppb, 10 divided by 500. How much it is? 10 divided by 500. 10 divided by 500. 1 by 50. 1 is 0.2 or 1.02. So you see here itself the column is interested. We are not able to give after this time of period. Our column is not able to give the free arsenic free water. Only for small division you will be able to give. Here or not here. So then you see this is another ACP column, similar study. You see the more time it is running and it's able to give treated water out of this. Okay. So that way study are made and to understand the performance in a lab scale. Then this is the water treatment unit. Okay. So here say we can put your 5 liter water, it will pass through this. We have maintained certain residence time, then we will get the treated water. But encouraging results. So this system was patented again, and this technology also was recognized by uh, the Confederation of Indian Industry last year, and I also IDOT got the first position on innovation, and then when you see the simulated groundwater water treatment unit performance at HNP KBTL, already I have shown you the last. In this case, what? Column height 10 centimeter, 75 ml per hour, 35 ml. So 10 ml per hour omitted. Because already we that we found that this is not workable. This main can be workable. So this is the ratio and 16 gram is equal to 4 gram is so 4 is to 16, 1 is to 4 adsorbent to make it cost effective. So this is the performance. Okay. Yes. And what we see, the parameters predicted by the Thomas model for removal of fluoride and different fluorides. So these you see that this peak of is 4.37 for this. Okay, and 2.137 average as well. So this specific aspect, if it is good, if it is more than 2, then that can come into the market basically. Come to the market. So these two FPL plus ACP hybrid adsorbent 30 ml per hour, 75 ml per hour. Okay, so then this is our adsorbent amount. Okay, 15 gram plus 4 gram, and this is and the liters of water used 6.7 liter and 12.3 liter, and this is the duration of the okay, this is our duration, and then they are using this is liters of water to take. Okay, that's if you take 1000, so that is 650 liters. 1 kg of adsorbent can give us 650 liters of liquid water. So that is the prediction we are making from the gas scale study. Okay, so we can make such type of prediction. Then we have to validate it. Yeah. Yes, yes. Okay, we'll have a break and then we are exhausted.
We'll have a break now. Everyone just don't have after the break.
My colleagues are. No, I happened is like that. Where is the secure? That's why I have. Once call, he said he is coming.
This is mine.
Yeah.
மெசேஜ் அனுப்புனாங்க சார் அனுப்பிவிட்டுள்ள
காலையில நான் ஒரு ஃபோன் பண்ணேன் ரொம்ப இது வருமா ஆக்டிவ் வருமா
Okay. After the way. Okay. Now we will have. Okay, we are going to know that 1 kg of this material contains 615 liter of water. Okay, with this contribution that 6 ppm of chloride and 500 ppm of. Now this goes some economic aspect of this. We compare with some other commercial environment which are available for this purpose. So the reduction capacity and your product name and then treatment cost per liter. You see this is 2.85 ml per gram is correct and or is 2.9 ml per gram and cost is here 0.36 INR or available only but here 0.18 INR because of that reason the process of production of material is different. Okay, and different material has been used. So that way it is cost effective with respect to other adsorbent. And this is the reactor as I told you. So this capacity is how much? We have 3 liter volume and then 2 centimeter diameter. So that has been scaled up. So this is your 10 liter volume and then 9.5 centimeter. So this is the final form of this product and we already tested in your certificate. Okay. And this is our performance. Say arsenic chloride, these are the initial concentration and after concentration, after removal, it is less than 10 ppb and here is a our adsorbent used that is 450 gram. So this 420 liter, 400 liter at 450 gram. So if we 1 kg around it will be say 800 liter like this. So that way which we have in our lab in field we are getting better result our lab result. Okay. This is actually tested prototype. Now we will see some working videos. So, it is self-explanatory. Okay, so it is clear to you how it is working. We need to replace or it is okay. Do we need to replace or it is okay? If you replace करना है or it is okay. So this is adsorption and adsorbent system. We are already in the final stage. Okay. Product is ready with it. Now we are talking about the household application. I told you the household application. Now commercial scale. Sorry, community scale activation. So what will be in a village, what unit will be there, where whatever will be said and through pipeline will be said to the individual houses. So the this is as per the plan of government of India. Okay, so we have to give pipeline to each household. So on that concept, this system, this method will lead to population-based system will be more suitable. So we started work in this system with this system in 2017. Even before that, 2015, 16. Initially, again we started in a batch scale setup and then in a continuous scale setup. The electric population for arsenic level in continuous scale was first reported by our lab. Okay. And this is published in this one and JEM and that was also recognized by current science journal. Current science journal, that was published in this document. So in this case, we have a small electrocoagulation unit, so that is 15 10 into 12 centimeter dimension, and intermediate size of this unit dimension 30-22. So this is the initial one, then this is another second one. So in this case, water is going through this, and then after treatment coming out. So this is continuous. And when we have there was no connection, there was no output, only for certain time it was the system was on, so there was batch. So now it is continuous. So the volume is this much, 0.5, 15 into 10 into 32. Okay. And then after that success, we this 30 to 20 to 22 centimeter. Okay. And in this case, what is the mechanism? As I mentioned that aluminum is dissolved. So anode dissolution. So aluminum 3 plus, then again going minus dissolution 3, and these are the polymer formation, polymeric aluminum hydroxide. So these polymeric aluminum hydroxide helps for the removal through different mechanisms. Adsorption maybe, quick coagulation maybe, okay, or ion exchange. Many things may happen in this. So these species are further transformed into amorphous ALOH whole wheat yeast. That is called according to complex precipitation kinetics. Okay, and ALOH whole wheat complex is linked to absorb arsenic by this reaction. So this is the reaction for arsenic removal, and this is the removal for chloride removal. The chloride and arsenic are not removed through the same mechanism. Okay, because there are some variations. The mechanisms we have adjustments on aluminum hydroxide particles are co-precipitations on chloride attachment to electrodes. So these are the different methods through which the removal of chloride can take place. The population which is taking place, this is very fundamental of the mechanism of electrocoagulation or the coagulation. What is happening? The collective particles are there. Due to the double layer formation, these are not separated. So you have to discharge this part. So by the addition of this collapse, double layer discharge, and then in variation of the changes, the aluminum oxides with the hydroxide is added. The bulkiness changes with change of pH. More the pH, becoming more bulkier solutions and then quantity, and when it settles, the pollutants present beneath this, so that also falls. So that is the sweet coagulation. Okay. So these are the mechanism for the removal of the pollutants. So pollutants which is present in the wastewater, those can be removed by this coagulation. Coagulation and propulsion, any difference here you can say? Coagulation and propulsion. This is the example of coagulation and precipitation. And propulsion also, this is your these two particles. No, two particles are separating. So for the coagulation, we need to bring these two particles so that agglomerate will form. mass will be density will be more and it will settle. Mass will be more and it will settle. Okay. So in that case, either two, but just like the two friends, we have some two friends, but there are some differences in mind because of some factors. After a certain time, we are realizing, okay, that is not right. We should again talk to each other like this, okay, or mix each other. But we are not. We are hesitating. At that time, one friend came. We make a bridge. Again, behaving like this, so that's like the word situation there. So that the some agent is engaged, so that these two, the ego which is there, the two double charge which is there, that has to be reduced. Okay, that can be done by either some mechanism, by external energy, that is done by slight agitation. Okay, or the flow. The flow that we also can do. Those are called that development is called propagation. And then once propagated, then the population starts. So that is these population conclusions all are responsible for this. Okay? And these are some EC-based systems, some examples. There are many researchers who are currently, so this is our research also. So we see that at P7 current density 10 amps per meter square, runtime 95 minutes, electrical distance 1 centimeter. This is giving 98.51% removal of arsenic 3, which is having 550 microgram per liter and 12 mg per liter fluoride, 80-20% removal. So it is the final method is below permissible limit. You see, with respect to any other literature, this is quite comparable and it is better. In this range, few literature is available. If we in this range, you will have not got. And both arsenic and fluoride are also not required. Okay, except this one. Okay, so that way, this was our unique study at that time. And then these are the initial, the 10 into 15 into 12 centimeter reactor. So 1.8 volume and fluoride 1.4 liter per hour, 60 minute resistance time, and power 30 volt and 0 to 10 amps. So here we are applying 10 amps and then we got this result for 1.8 liter. Then we designed a bigger one, so that is your 60 40 80 48 so 150 liters. So hydrogen collection facility, that is the second facility about it. And then we developed another. We have 1.8 liter, then we got 20 liter capacity. So this is our 20 liter capacity. And after treatment, we are giving the heated water.
Staff electrode
Yes, aluminum. Filter, and then clock settle in the reactor. This is our reactor. Ignition time with this 100 liter reactor volume. As I told you that we need to increase the volume. So this is in the high 100 liter volume. Right? Now, if the working in this. Yes, synthetic waste color in lab. So then your 3D electrocoagulation process they give you different units here. So after treatment we need some other treatment also. So this is our filtered water And now we are going to field. So this is the real field we have identified. We have visited the place, and you see the economic condition of the people. Very poor people are there. So we have to do something. Basically, in the field also we have tested the field level. This one. Okay. This is a field level study already demonstrated, and these were funded by DST on the water technology initiative. Okay. So it will targeted to have say 1,000 liters per hour capacity, but we have got 2,000 liters per hour capacity, and even more than that. We have some limitation, we can increase it more than that. So that is for the particular case, because the right concentration is not that high. Potassium is very high, potassium is about 1,000. So up to 30 feet, the maximum fluoride concentration which is reported so far, our plant will be able to meet and will be able to work on that. Okay. So we started initially, and then to some extent we are able to achieve our goal. Okay. Now we have to commercialize it. We have to put more effort to convince people and to put the plant in the real side. And the cost will be like this, 3 paisa per liter. Okay. The cost will be less. And another question is the sludge management. That is a big issue actually. I am told the pollutants I am taking to from water to solid. They are not very good.
It deposited on the electrode. Deposited.
Yes.
How long it will take to treat that?
How long? It takes 90, it takes 20 mg material for 1 liter, and fluoride concentration is around 8 mg. And in our lab, it takes 96 mg of metal for 1 liter, and fluoride concentration is 8 mg and 6 mg, and arsenic is 5 mg. How much? 96 mg, 0.096 gram per liter. Okay? You will not get it in here.
The groundwater is not taken the value but the issue. What is the property that when you are looking into the particular ground
I have told you.
it seems like
Groundwater simulated groundwater.
I have one more. Yes, my study the reactor, 1.5 liters. And then we have to do all the electrodes, what is the medium that you put and what about the leaking volume and electrodynamics.
Thank you very much. That will very
And I also made some digital games, holding the electrode on the top of the reactor. Particular medium and we have to detect the electrode in vertical zoom and the application device how we hold on it and how we use feed on the anode side. How can we hold on that and one of the regarding the values and we are
no, no, you have to be in the electron after starting the
and that this medium we have used for that.
For a lab, as you bring piece on that, take some paper and
Then already this fascinating can be moved. Now you said in 16 again you have kept the water electrode and the supply.
what are the water which you have?
Daily electrode.
Whatever the sample you have, it is directly taken to the
Yes,
sensor.
sir. And the doubt I had with your reactor is that the unit itself, like you connecting anode, like positive and negative ability in microarc, this is a electrode. How do you keep that electrode vertically in the medium?
We do not have any medium.
This is support.
Support that you have to decide.
It
It may be plastic, it may be wood, it may be
what making it
plastic.
the whole metal and sir, the steps that is using this react water. But like factor, we it's a chance of both elimination and rotation. Now you are
No, the cross correlation you know, you cannot give a solution to all problems by one device. You have only people. So you have to identify suitable. This system isn't applicable for you. Where cross correlation will be neglected other things. But in this case, there will be no problem. We do not have
in my case both are there.
but it is it has very high CO2. So at times you will not want. In the next lecture, I will get some idea. Okay, I'll say that one. In the next class, we will discuss you will get the response of your training. Okay? Any more? Okay. Okay. So then, the material which is generated, one process is break formation. In lab, the alumina that is the agent which we got that was of this red color. Sorry, this white color. But in the field, we have got black color. Okay. Same material. But in the lab, it is white, but when against the field, it is became another color. Because the presence of other components in the okay, which we are not able to identify at that time. There are some other materials. Okay, so we are also between. This is one is your brake formation. So if we use this in the brake, certainly the quality may be deteriorated. It may be improved also. But in this case, quality is not improved, but not affected much also. Okay. Up to certain percentage, we can use this material with a brick material for brick formation. The margin. That is up to 20% of this bulk we can use so that its quality will be as per Indian standard. The quality will not be of lower grade. That will be great. But still, there is good scope for you to use these materials you need for around 20%. Then question is coming, okay, what are you doing then? What are the properties of this? So you see your compressive strain will be there. Okay, then your and the leaching properties, whether the arsenic or fluoride which is captured by the material, whether those will be leached once again from these or not, that will help you ensure. Okay, and these are the arsenic uh, uh, okay, so this provide how the leaching is coming out. So how we can do this leaching test? Leaching test is done by your TCLP test or this weight test, California weight extraction test. So this by extraction method some solvent is added, so sufficient time is allowed and rotational proper mixing is allowed as per the standard. And then what is the contribution of pollutants coming out leached into the water that is result. And it is found that in this case, if we follow this process, the leaching comes, but this is the limit. Okay, as per the standards, what should be the limit? It is far below that limit. Okay, and the properties are also to some extent deteriorated, but not much. Up to 20% we can use. After that, if we want to use more than 20%, then the quality may be affected. So that way, one route is there for the utilization of the sludge. Another route is the catalyst formation. We can use this material as the base for the catalyst. So we have made some catalyst from this material, and we have used it for the pyrolysis of biomass. And the pyrolysis of biomass, we are also investigating on the pyrolysis of plastics, waste plastics. We have seen that particularly the phenolic compounds enrichment is taking place in the product. So while this is produced, we are having a typical type of more concentration of phenols when you use this catalyst derived from this material. Okay. So there is no apparently you have not been able to identify any negative impact on it or with from this artificial chloride sample. That way we can use. Another sample we can use here for the paver block and tiles production. We have developed another technology here for the production of paver block and tiles from waste milk packets. So waste milk packets, adding this material to some extent, not completely. If you use completely this material and this will be vaporized, it will crack, so we will not get product. But certain extent, certain like 10%, with other additives we can use and we can make this that is the paper blocks and tiles, etc. Okay. Then you want to so 2-3 routes are there through which these materials can be investigated, can be reused and validation can take place. Okay, so now I am taking some advantage to show you this slide. This is on the basis of these investigations of those plastics. We have uh, we have started one startup basically that Glass Green Tech Private Limited, and this is our product. This plastics to this, and these are our advantage of this. And this material is demonstrated in IDOT, and it is around 1 year it is being, and the product is remaining as such, the quality is not affected. Okay. So we are trying for the commercialization of this product. Okay. So so far I have shown you some lab to commercial, semi-commercial scale transformation to make now what topic is sustainability. This is fine, but our process has to be sustainable. So that part is remaining. We have to discuss that. sustainability. In this case, particularly, we are talking about life cycle analysis. Okay, sustainability is bigger than life cycle analysis. That we will not talk. Okay, we'll be talking about the life cycle analysis. Okay, so some investigation we have done here with this the initial material which we have developed as ABTL to ABTL acid base or acid treated or stable thermal treated. Laterite, thermally treated, acid treated, acid base treated. So these three cases, then which one is more suitable, environmental friendly, which one is? So that was investigated. So what is done? So if we see the life cycles of this, so mining, then from mines we will get the mine the ores, so that has to be transported and then transported to the factory premise, then your screening and then crashing, then you will go for chemical treatment of the dry cell. Okay, sorry. We are confusing. This is not for that alumina. This is we are talking about lateral cell. So lateral cell will have to come from some area outside to mine, and then it has to after screening, size reduction will be there, and then after scratching, and then chemical treatment, and then we are getting the heated lateral cell treatment here. Then water treated water will get, and another will be what? Starch or the adsorbent, spent adsorbent, then that has to be managed in the break formation. So these are our life cycle. And then in this life cycle, okay, then for life cycle study, our objective is to fix a goal. So our goal here is to know the impact of these three adsorbents for the treatment. So particularly, then we need to fix one. We need to do inventory analysis. For inventory analysis, we need some system boundary. So what is our boundary for our investigation? So here collection raw laterite, then size reduction, then transportation, then this is then washing, then acid treatment, and then your heating at a living centigrade. This is acid treatment, then distribution of acids, then heating, and then defluoridation water treatment, then your sintering of bricks. So then the material is going for the brick formation, and this water is waiting for use. And for this sintering purpose, we are using electricity from biogas. So this is our, and here acid treatment, we are providing electricity from grid, and surface multiplication of raw adsorbent is used. So for this case, we are using electricity from the grid. Okay, and this is for acid treatment. This is for acid base treatment. So here acid treatment, then again base treatment. This step is added. Again washing, again drying, and again defluoridation, and then sintering. So this process will change. That means the system boundary is modified now. So we will do now the inventory analysis. So for inventory analysis, we need a basis. So that is 720 liter water treatment is the basis. So we want to produce 720 liter treated water. So for that, how much adsorbent will be required for three cases? And for those, for the production of that much of adsorbent, what will be the raw material requirement? So that inventory analysis is done. And on the basis of that, your environmental impact analysis is done. The environmental impact analysis is done by using some software. Okay, and we normally use Siemens method one method and Rashi method. So these two methods are used for the analysis purpose. And here you see the CML 2001 ABTL. So we have different parameters. So these parameters are index of the LCA. So what are those? Where you see acidification potential, global warming potential, eutrophication potential, ozone depletion potential, avoiding depletion potential, avoiding depletion potential fossil, okay, and this is elements, and fresh water, affecting eco toxicity potential, human toxicity potential, okay, marine aquatic eco toxicity potential, terrestrial eco toxicity potential. These are the different index which have been included in the LCA analysis, and different softwares you can use. So we have used Gavi software, and that basically uses the European data set, and there these 4 or 5 cases are considered. So that is your truck. Okay, the electric is now, you see, if you compare this one, so global warming potential, 1, 2, 3, 4, 5 different different symbol you are getting. So here, trailer. So this is giving maximum for the transportation, the fuel is used, so that gives maximum greenhouse gas emission, and then we are getting the electricity from biogas, and then electricity from great lakes. So great lakes is giving more, biogas is giving more, less like this. So that is the rest is this one. So these are the composition, contribution of different activities on the greenhouse gas emission. And here also acidic potential or ozone depletion. So all activities have not similar contribution to different potentials. Okay. So overall, this your tractors for the transportation plays a significant role for the creation of pollution. Okay, and then electricity from the grid, which is used for the absorbent preparation. Okay, this is now if we normalize this data. So TTL, ATL, and ABTL. So we see in which case we see the impact is minimum from this figure clearly. ABTL less, somewhere it is high, somewhere it is less. So where is greenhouse gas emission? The greenhouse gas emission, which one is less? TTL is less. Is it? So ABTL and both are having some. So that is the different processes are having different your environmental impact. Okay, that is called adjustment process. To ETL, ATL, and ABTL. And then different scenario. So scenario 1 is your draft filler having highest on carrying capacity and distance 5 km. So mining to process site 5 km. In draft filler having highest on carrying capacity and distance of 10 km. Another is draft filler having 12.4 ton capacity and distance 5 km. Fourth is your tractor having 12.4 ton capacity and distance 10 km. Fifth is your a tractor having 70.3 ton carrying capacity and distance 5 km. And a tractor having 70.3 ton carrying capacity and distance 10 km. So these are different scenarios. So out of these different scenarios, can you guess which one is having minimum impact? Yeah. From figure, which one is minimum? Which one is minimum? A. What is this? This symbolic of what? 5 ton carrying capacity, 5 km. Okay. So if you see, if distance is more means, what we can conclude? Distance is more means transportation, during transportation more emission is empty, more greenhouse gas. So as less as possible we have to fix that. the distance will be as less as possible. Second is we have option. Okay, we can use say I need to transfer say 10 ton of material. So I can choose 5 ton 2 times or I can choose 12.4 ton 1 time. Okay. So then, but if we go for lesser capacity, then as per this data, it is getting better. You know the problem. Okay. Now we will see, we will compare. This is our earlier study, but now we have to compare between absorption and electrocoagulation method when we are doing the same process. Activated aluminum, which is generated from the electrochemical process. One is absorbed, then it is sintered and then used for absorption of arsenic chloride, and another is in situ arsenic chloride capture is taking place. Then we are converting into the material. So that way, one is your mining, then transportation, then processing in industry, and then aluminum plates we are getting. This is aluminum ore, it is aluminum plate. Then we are going for electrolysis, then drying, then we are getting calcination and absorbing. Then absorbing is formed. So here treatment, then clean water, then spent absorbing, break formation. Other process is different. So first part is same. After aluminum we are getting same, but this part is not there. We are directly getting the removal of fluoride and arsenic, and then the sludge we are getting, and we are getting clean water. The sludge is going for filtration, drying, and then we are getting. So this part is different. And because of the variation in this part, the environmental impact is changes drastically, and I will show you. So what is our objective here? 720 liter water treatment. We have to 720 liter water treatment for all the cases. Then how much material will be used? How much energy will be used? So that inventory analysis we will do. So in this case, what is this? Aluminum sheet we are using. Then the electrolysis process, and then adsorbent will be formed, and then that will be drying of weight adsorbent and calcination. Then wastewater treatment. Then your break formation with the spin and water treated water will get 720 liter. So in this case, depending upon the specific uptake of the adsorbent which is produced from this aluminum, we have to fix the aluminum requirement. Huge mass we need to have with respect to this one. But here we are following the same process, but here we are getting the removal. We do not need the calcination. Directly we are getting the drying of sludge, and sludge is used for brick manufacturing. So here volume of water same volume of water we want to treat, two different processes, different material and energy requirement, and so different impacts we will get. Here, how we will do? We need the help of your software, and before that we have to give the inputs to the software. What is my inventory analysis? What are the different materials we are using for different cases, and energy we are using for different cases? So that we have to do here. This is for your process input output, and it's process included in life cycle inventory of adsorption. So this is our adsorption process. So we have aluminum required 1.05 kg, fresh water 50 liter, initial 170 gram, electricity 36.22 kilowatt hour, water 6 to 7 liters, the request, and weight adsorbent 8 to 9 kg. So 89 kg adsorbent, weight adsorbent we are getting. Okay, and that will be used for the production of 720 liters of heated water. And drying of weight adsorbent at 105 kg, that also requires some electricity, and water vapor will form, and dry adsorbent, how much it is 8 to 9 kg to 3.06 kg we are getting here. And after that calcination, again electricity is required 2.75 gram we are getting, kg we are getting from 3.06. No, sorry, this is electricity requirement is that. Okay, spent adsorbent management we have to do, and brick manufacturing for this. Okay, spent adsorbent is used. Here also we need cage, we need electricity, we need water. So 20% water, 20% of brick, this water remains. So these are the different materials, inventory analysis, material requirement and electricity requirement. In case of electrocoagulation process, you see here aluminum required, contaminated water, how much this is 903 liters, 1000 liters. So here our base is 1000 liters. Okay. And initial required 360 gram electricity, 5 kilowatt hour sliding, so how much it is generating, and kilowatt hour how much generated, 730 liters. So evening is sludge, so 903 liter water we need to take, and drying of sludge, by using this one, electricity, wet sludge, dry sludge, how much, water, evaporation, how much, and then the calculation is the last part is we have. So brief formation, so clay required, electricity required, water and water will come. So these are the inventory analysis for two different processes, and to solve it, we need to assume something. Some cases, some data are not available. We need to assume something. Okay? For what some assumptions are there, the environmental impacts of manufacturing aluminum plates have been directly taken from the garbage collection of database, which includes the impacts of mining, collecting, and transportation of oxide, and the drying of wet adsorbent and sludge scale has been performed in a hot air oven with the capacity of dry 50 kg of wet material at once. So we are going to handle larger volume of material, but our lab do not have that capacity. So we have to take some assumptions which will be near to the reality. So what data we are getting in reality, that we will handle to some extent. Okay, but we have tried available ways to give some assumptions so that it will be near to the reality. So again, filtration operations has been used only for electrocoagulation start, but due to the lack of reliable data for the field scale operation of electrocoagulation, a manual base was considered for this low capacity operation. Also, the energy consumption in the hydraulic filter press calculated based on the power rating of this paper. Okay, that will less than 1% of the total energy consumption. So that way, which data was not available, we taken some assumption for justification like this. So this is a normal process. This process is followed regularly in research. Okay, development. Nothing new. And the environmental impacts associated with the transportation of materials for the treated unit are negligible compared to the impacts from material and energy consumption in the treatment process. So this step has been omitted from the flow diagram. Again, so that way different assumptions we had to make, and then electricity used in the sintering of brick has been produced from solid biomass. So solid biomass is viable in abundant quantity in countries like India. Solar energy can also be used for the same, but brick sintering requires high temperature and it has low energy density. So these are the considerations why biomass was considered, and the electricity consumed in pumping the groundwater to the treatment facility has not been considered, as it is common for both the cases. Okay. The environmental impacts associated with the crushing of dried precipitates in the synthesis of HNP adsorbent are negligible compared to other processes. Also, in manual hydraulic press has been used to cylindrical shape adsorbent. We do not have any machine and we cannot get that data. Manual data has been done. Good, but we have to mention because otherwise our result will not match with reality. It will be plain. Okay, then impact analysis. For impact analysis, two methods are basically used, that is CML 2001 and TRASI. Okay, so the CML 2001 is basically developed by Institute of Environmental Sciences at Leiden University, and TRASI is developed by US EPA. So the European and US database. Indian database is not there, but SIMAPRO is under development. SIMAPRO is another software is there that is also used for this analysis of Indian database. Okay, so this TRASI and CML, the CML method and TRASI method, different methods. When CML method has 11 different categories of impact categories, or you can say that index categories. Okay, and TRASI method includes 5 similar impact categories but with different impacts. Okay, indicators. Indicators are different, and both are both CML 1 and TRASI follow the midpoint oriented approaches that characterize the impact categories or the impacts which are directly caused by the immediate pollution. So what immediate pollution that will give impact to the human health? Okay, that intermediate midpoint categories are considered basically, and these are for example the Siemens 2001 method represents human health as human toxicity potential. Tracey has two different. This is under two different categories. There is human toxicity non-carcinogenic and human health particularly carcinogenic and non-carcinogenic. In human toxicity, carcinogenic, human toxicity, non-carcinogenic. So two, but it has only human toxicity potential. So that is some variation in that. Tracey and stable, but they are basically that. And total impact caused by each operation and process by stable one, if we adjust and the electrocoagulation data is given. So these data are also shown in the figure. So aluminum plate, so your electrocoagulation, so drying of the coagulated material, and then electricity used in case of calcination, and then deformations and rest. So these are the different major sources where the pollutions are coming. Aluminum plate formation, electrocoagulation, drying of the materials, calcination of the material. This is what adjacent case. So these are the different related combinations. So the yellow one, that is brick formation, that plays major role. Okay, and then aluminum plate formation, and then electrocoagulation. Other are less, but in other in some category, others also play major role. So depending upon the nature of the indicators, the contribution of different activities are also varying. So this is for and this is CML, and this is your Tracy method, different indicators for adjustment. And this is for your this is your comparison of impacts using CML and Tracy method. Okay. This is your electrocoagulation. So aluminum resolution required for adsorption and electrocoagulation process is 1450 and 194 mg per liter. So 194 mg per liter and 1450 mg per liter. So these are the requirement. As a result, if you compare these two methods, adsorption method is having very high impact for all categories with respect to EC. So we can say now on this data that EC process is much more environmentally friendly than the adsorbent process considered in this case. That is activated, that is your ANHP based adsorbent and alumina electrocoagulation. Okay, so we have reached to the end of the discussion. Okay, so now we are understanding that electrocoagulation process which we are proposing have good environmental impact with respect to adsorbent process. It has potential to be applied in the commercial scale, and it has the potential to fulfill the dream of the country with her job. Okay, so all those it has potential. Now we have to be use it to make people convinced and to set up plans. Okay, and this is one video. Just last this again. I have got an opportunity to I'm showing you. Okay, this is our. As I told you, the Okay. So thank you very much. Okay, so the last video also related to this electrocoagulation process. We can use that slide to this. Okay, thank you. Any question?
It's open for questions now.
So if the concentration is very, very high, so the solutions, so fluoride is removal and fluoride position are based on whether the concentration is very high or very low. Say for example, I would do a primary treatment and remove it by some sedimentation and then I polish it using say the electrode. Can you use this primary for when the concentration is very, very high?
Yeah, right. Very nice question actually. I will give you some more data on this in the next session. For the time being, certainly this is not applicable for very high density. Up to certain limit, it is applicable. If you want to apply for high density, it may not be for operational difficulty.
So like the polishing step instead of like the traditional absorbent, it's going to be a more suitable technique.
For groundwater, no issue. Because the concentration is not that high. But I am talking about industrial.
The problem is possible.
For groundwater, any concentration it can be okay. Because that capacity it has.
So this brings me, sir.
Yeah, so now 12 o'clock. Last time.
During leaching, during rainy season, leaching, again, this has any control.
Yeah, so that I have told you, know, the WP test we have done it. So it's not necessary that you have to prevent 100% release, but there are some guidelines. So that our product is giving some release, but that is far below the standard. Far below the
That study has been done.
yes. Otherwise, we cannot create.
Maximum voltage is for the fire. 30 voltage.
Other plant we use in 30 volts, but we cannot go up to 30 volts. To work from
Lesser than
you do not need much voltage. If you apply much voltage, your power consumption will be higher. The loss will be higher. We have to reduce the power consumption. Yes, you can do. You can many other methods. Iron technology.
and it has a lot of discussion problems.
Not like that. Iron is used for oxygen production.
Iron helping their body. Many other elements.
You see. You see the fundamental. I need more positive charge. Aluminum and iron class 3 will give more than it. Is there any method? That is very it will capture more ions. That is why people use aluminum. Cheaper with respect to other metals. You will go for sodium or it will not work. So, have to go for S3, class 3, I don't know aluminum. Otherwise, we can go for other mechanism, that is lithium like this. So those will not be associated, those will give some electrons.
Nowadays, the iron is lacking proteins.
Yes, yes. No resolution will give. They will give electron, and electron will do the next for the transformation of the elements of one form to other. And then I have given carbon one example. That is why they repeat that.
It seems like the iron hydroxide itself does will form a lot of sludge.
Iron.
Iron hydroxide itself will form sludge.
Yes. Yes.
So, like this, by adding iron to the icing system, we can produce like more sludge.
Yes. Yes. That is there. Another is your aluminum. Iron is heavier than aluminum. Aluminum is ultraviolet is listed, I think. So that we want it, and the iron, iron can convert certain type of voltage form of color, like arsenic or arsenic fine.
Okay.
Aluminum cannot do that.
Okay.
But aluminum has more annexing facility. So it equally able to capture arsenic without converting it into arsenic fine. So that was a big doubt. When we hear the paper that communicate without conversion, how this can be possible?
Will this
It
also
is possible to do that.
so like will it be used with liquid with chromium 6 plus ion 3 plus do you think that goes better?
Yes. Chromium can be removed by this. Where the good person? Chromium will be. But only that very high concentration, we should not go for that.
So, the, so like the electrode energy or like the electric potential. For AC analysis, you assume that it is solar derived or the normal.
No, we have given different options. So grid connection pole based,
Okay.
and then biomass for grid formation.
Like if it's solar, it is not.
No,
So like,
we have done it your scenario analysis.
okay, I understand.
That's
Solar also. So the last graph we showed like the lowest, smallest atom. That was using solar or
No.
that was using normal?
Yeah.
Solar also can be.
This is the real theoretical study.
Yeah.
You can anyway
So like, I mean, if we make it solar, then it should be even more.
Yes.
What is the cost of that activity? Product. Converting the plastic to.
These have two models. One is for say small scale model, like say NIT caliber. A government as per our solid waste management 2021 rules, amendment, all organizations producing waste has to manage it. If it is applied strictly, so NIT has to manage the solid waste. ITRUD has to do it. Okay. That's the time what we do. See how many, if you have 6,000 students, say 1,000, 2,000 staff members, 8,000, 250 ml of milk per person. So how many plastic bags can you compare? It may be days per day. It will be 10 days per day, at least. So that is plastics you can collect it easily with putting less effort. Your message people will be can be possible.
Right, for plan within the list generated in the IE.
Yeah.
It was not at the same time.
It is very now. But we have to very soon we have to do our own arrangement. They are getting again and again reminder from the administration to something. So this for this institute we have one model. Okay. And army, easy army and Virat army, they are going to install two plants. So negotiation. That is one model. Another model is for municipality. So if you get one investor, they'll have some tie-up with the municipality will make highways contract for supply of the materials. So they are going to be bigger now. Okay. So that two different costs in there. The first case we have cost around 25 lakhs, 20 to 30 lakhs. The equipment, and for the second case it will be around 50 lakhs. That will be double.
The market must be.
Yeah. Okay. And then this 2.5 years payback period. 2 to 2.5 years.
When you have sometimes with this switch to bridge, if the switch is actually very slightly as an element which blocks the push, what do you do to the push? Like I have had some systems like where because of the fluoride and iron oxides, when you try to filtration of your control, you block the force and the force the back to the right. So in that case, like how do you uh,
Actually, depending on the nature of the star, the filtering capacity will change. We have to analyze our system first, which is what is the characteristics, what is the sludge volume takes, and then we have to select the process. Normally in industry we can just settle nowadays, so we can settle all type of tasks. Okay. That is set to do this, solution to this. And also use can be used
because fiber reinforced plastic.
thinking is very good. There is no harm to it. But all the systems will have their own prospects and own limitation. Whichever is more suitable with your system have been done. Nobody can help on that matter. You have to choose. Okay. But from literature we can get some idea that say if non-condensable starch. Okay. So then in that case you can go for this pain and filter which we are using in our case. Otherwise, you will go for centrifuge. You can test. Nature. Anything else?
About the easy possibility of that, because I it may lead in a context.
I think the temperature up to 140 degrees centigrade, it will not melt, not soften.
And what about the hardness parameters?
Hardness and physical parameter means one is your compressive strength, which is that is 35 megapascal. Okay, so that is tested. So that is more than 35. That is for medium vehicle, cars, etc. And I have one, 1 year is over. So almost 1 year, not 1 year. So we have installed it very fast, very last year. So I'm very much significant. So there is no change. And I will itself want to install again more and more. So we are now developing our capacity. So just now we have got the number. So we are fighting. I don't know what will happen, but we are putting our effort. Okay. Leaching is not there. Leaching is a best. We have tested leaching, we have tested your water penetration capacity. That is also no problem. We have tested the mold formation, that is your algae formation. There is no from that type of it is tested. So you might say there is no after 1 month, 1 year or so, no staining can be done. Yes. That is tested. So this is basically our test. Okay. 1 year as a real environment. If the get what, it will get more regularly now. That is only a useful all we will have to come. That is what we are reading the test now. In future, we can give more information.
I will say it's great for that thread. How to difficult for that. Okay, okay, for the render, and they have to
Yes, the very nice question. You see, one is plastic, another is plastic composite, polymer and polymer composite. So, in case of polymer composite, we have one matrix, and in between we put some reinforcing agents. When reinforcing agent and this plastic mixed together, then neither the property of neither these elements, the fixed property we get. The hydrogen and oxygen, it is reacting and giving us water, water will not give the property of hydrogen and oxygen, right? It won't. Composite has no property. So why not worrying about that it will give the sludge is not remaining as sludge there. Sludge is between intermediate in between the particles of polymers and those are connected to each other. So water will not be able to give it. So I would bond with it. Sound is coming. Your bond is less stable. Okay. So that is the case. So the polymer composite is the bond strength is much more. And the water and polymer and water and this. Any question? Is there a easy process?
Electrocoagulation process continuous operation.
Yes.
Yes. The water the vacuum will be that it is in the process by doing a continuous process.
I have not placed here that much of
Electroclassification and speed.
yes, that
I have not seen it in other how long are you going to and find the protocol that you follow that more
that depends upon the system.
like in that span or something like basically it's providing drainage system at the bottom and
Yes.
in my opinion that like environment was my company technology.
No, it is downward. So why I'm not going so wastewater is talking this in this class we are not talking about anything wastewater. The complaint is talking about groundwater. I will talk about wastewater. That kind of question I understand. Now let us focus on the groundwater. We are working to give a solution to the groundwater, not what is wastewater. Because problem varies. Groundwater and wastewater are not of same property and same thing. Okay. So this is particularly for this case. Next session we will discuss when you are working in that area. And we will discuss that. Okay. So anything else?
The reaction you have used the reservoir was basically kept in the handmade and then the sample water tank that we actually made on the experiment setup. The base water was kept in the reservoir for the ground area and you had used the textile pump for the take of water to the reactor. So instead of that you have used the potentials.
Yes, that is the thing. In reality, potential gravitational force has been.
Yeah, that would be replaced.
That has been. In real plant, that has been. But in industry, we cannot use it because we need to understand the impact, whether downflow or upflow, which ways to go like this, and into inhibition creation, then any limitation analysis.
Yeah, scenario what will always be controlled. That would
Yes,
be
yes. So reality we have always done. The first time you complete and water tank is there, in the water tank, other tools will undergo.
and the operation of the guiding blocks and all. But in tester can be like that. We contact with tires and all.
Yeah. Yeah. I told you, no. 1 year field demonstration has been done.
I seen that no, and other than that, any
Other than laboratory
condition,
condition,
yeah.
under laboratory condition it is. All standard tests have been made. And first all the tests.
it becomes similar to
Yes. And we appreciate it. But yeah, these are quality. So, you do not have to call it, you will not appreciate it. That is that.
Right, considering going like it's hardware compression language.
Now, for the common people, first question is what is the cost? Second question is how long it will
Yes, yes.
last.
Primary aspect.
These two questions are there. Okay. Now next in coming years, next generation, our question will come, question will be there was no issue. Not now. What is that? Next time.
If it's having that's then the recycling of that will be another question.
Yes.
That's it. That
It will recycle.
can be recycled again.
Yeah. Then awareness is being created, and that is why we are working on that.
Anyway, that studies and all that's why we also keen to ask about this.
Yes. These will be repeated questions we have already got that. Okay? Yes. You got it? So I think there is no more questions. And yes.
Thank you, sir. This is an informative topic. Now I invite Dr. B. Shivasubramanian, the first Pradesh. Now I invite Dr. S. Bhuvaneshwari, Associate Professor, Department of Chemical Engineering, to deliver vote of thanks. Good morning, everyone. I thank Dr. Prasenjith Mondal, sir, for a very informative talk on electrocoagulation methods for arsenic and chloride removal. Actually, getting speakers for online session is very easy, sir. It's very difficult for getting offline session, but you are great. You have traveled a long distance and joined with us. Thank you, sir. Thank you. Very nice lecture.
Thank you. Thank you.
You have a good day.